S equal to d by t. In an experiment, d and t are both measured correct to two significant figures. When d equal to 7.6, t equal to 0.23, find the upper bound for S. First, let us write lower and upper bound for the given numbers. So, starting with d, that is 7.6. What should I subtract and add to get lower and upper bound? How do I decide it? We decide it in this way. Both are correct to two significant figures. They are rounded to two significant figures. That means earlier there were three significant figures. Okay, earlier there were three which got rounded to 2. So now what you should do is, these two significant figures you should make it back to three significant figures. And how do we do it? See here. Here will be 0. If I get a 5 here, then only this becomes three significant figure. Clear? Now to get 5 over here, I should add 0.05. Understood? Now whatever you add, subtract the same thing. So I get 7.55. Clear? Now the next number is t. Now, what should I subtract and add to get lower and upper bound? How do I decide? I decide in this way. See, even this also correct to two significant figures. That means earlier there were 3, it got rounded to 2. So now you should make it back again to three significant figures. So what should I do such that it gets converted back to three significant figures? Is this. See man, here it is 0 now. If I get a 5 over here, then this is now three significant figure. Accepted? Now to get 5 over here, I should add 0.005. So whatever I am adding, I should also subtract the same thing. So when I subtract, I get 0.225. Clear? Now, given equation is S equal to d by t. We have to find upper bound for S. See man, for S I should find upper bound. Here you should analyze. This is a fraction and the result should be an upper bound only if the numerator you take upper bound and the denominator you take lower bound. In the fraction, upper by lower will result in upper. Clear? Now let us replace the values. So for D, upper bound is 7.65. For T, lower bound is 0.225. Put this thing in the calculator. You get the answer to be 34. This is the value for S. Is it clear?